Yeah,
Shiva,
so
I genuinely cannot thank you enough for presenting. The vortex fluid model, I mean, it's super important for visualization, but also just from what I've studied, like, every time you discuss that, it just for me, it clicks. I'm like, "Yes," and it's one of those things that gets stuck in your brain. I think it takes a while to kinda sink in, and once it does, it's just this incredible visualization tool.
yeah, I have to go over it a number of times with people generally because there is so much to it. But it is something that I've been calling the neoclassical revolution or the neoclassical interpretation for some time now in a few of my published papers. I think you're going to have to actually put it on the screen for me to be able to manipulate it. So
Okay, there we go. And
there
I
we
will take myself out and go for it, sir.
Actually, let's try the other one. I just want to see if it actually shows the animation. Okay, it does not show the animation. That's why I brought the other one. All right, that's good. Let's go back to the other one.
Okay. So I'll go back to the other one then.
Yeah.
Yeah, StreamYard has a lot of advantages. It does have a couple of quirks. It makes you do videos and animations and stuff separately, unfortunately. But to be honest, the benefits of it kind of outweigh the minor drawbacks that it does
It
have.
really does. Yeah, it's a great tool. All
Okay, well,
right.
thank you again, sir, and take it away.
All right. Thank you very much. All right. So I'm going to try to run through my slides as quickly as possible because this is sort of an overview, and I plan to do more deep dives in the future. But this is basically to introduce a set of concepts and show you that there is basically this single through line for revolution within modern constraints. And so, for some time, people have known about the issues with the vacuum energy catastrophe, all of the various issues that we're having in physics. There's quite a lot of them. As much as we would like to downplay them, they are very, very big. Matter of fact, one of the ones I like to point out is with the cosmological constant problem is it is equivalent to expecting a measurement the size of all atoms in the universe and measuring one atom. That's the difference between our expectation and measurement when we're talking about that particular problem. And there's quite a few others. So let me move over to my slides here and move to the next one. Okay, so one of the things I first want to point out, as a historian, I am not trying to put myself as the origin of the neoclassical revolution. It's been around for a very long time underneath the surface since, for over 100 years, but I'm going to try to bring you to some of the history so you understand where I'm coming from, and so you can kind of dive into it to yourself, and hopefully, after you've allowed some of this presentation to bake a little bit, you'll be able to go back and look at, when we deep dive again, you'll have some ability to look at some yourself. So I want to bring up some of the most recent names in what I call the neoclassical interpretation or the neoclassical revolution. Ross Anderson, I wanted to bring him up first because he recently passed away, and he's one of the people that introduced me to a more modernized version of soliton models in fluids. He worked with Robert Brady. He consulted with Steve Moffat, I think, is the other physicist there at Cambridge. But he was a security engineer at the head of security engineering, and so he was a software engineer, etc. Much more than that, of course. And he wrote a paper that you can find in the archive called Maxwell's Fluid Model of Magnetism, as well as a few others. Unfortunately, for some reason, these papers that were very, very powerful are not found on his Wikipedia. Then I wanted to introduce you to Yves Coudet. He's responsible for one of the biggest recent developments in what I call the neoclassical revolution, and he invented the silicon oil drop experiments, and we're going to talk a little bit more about them later. Then John Bush, he took these experiments, which were being performed by a number of people in the community. He's in the fluid dynamics department at MIT, and he has now published something called Pilot Wave Hydrodynamics. And then the other person I tend to think of, and this is just a very small subset of the people working behind the scenes for a very long period of time, and these are the recent ones, and that is David Finnick. I hope I'm pronouncing his name properly, but I just want to point him out because he's owned neo-classical-physics.info for quite some time before I actually decided to coin this interpretation by that exact same name, and ended up finding that he is the original translator of the Kosrat paper. And that's the Kosrat sort of book in 1909, and that it now has led to what's called micropolar elasticity, and that is a big part of the picture that I'm going to introduce you to, but we'll get to that in a moment. So what is the neoclassical revolution? It is revolution via interpretation. In other words, so the biggest question that you have to ask yourself is, how can we have a revolution when we have these measurements that are so perfect? We have so many experiments. How is it possible to have a revolution? How is it that we can have such perfect, such, absolute, finite calculations that are working perfectly, and then also having these ones that are so incredibly out of whack? And that is why I'm saying that we can do this via a change in interpretation. And now, a lot of people are going to have a problem with the idea of trying to make a change in interpretation. And so what I want to point out is the map is not the territory. And what I mean by this is that whenever you're doing mathematics, what you're doing is an analogy. You are representing something. You are cutting it down, and being able to match the map to the territory is what makes real metaphysics. And it's that is the intellect type that lies beyond calculators and stochastic parrots, the ability to map those things, to figure out what math should be used, not just simply calculating, not simply memorizing and regurgitating. So that's very important. And I wanted to point out a couple of things to basically get us back on the track of the value of real metaphysics. And that is, how do you map this analogy of a mathematics and what it is that you're modeling, and not losing yourself in the mathematics as just some sort of pure pursuit, but a real actual pursuit of modeling. So what is the value of theory? And so I want to talk about what I could call the pragmatic validity limit. And a story I often tell is that there is a tribe in Papua New Guinea who prays and sings to the fishing tree, and in response, fish rise to the surface. This is basically an empirical science, because you can go watch them do the ceremony, and fish will indeed rise to the surface almost every time. And so the thing about that is that it is a neurotoxin that is in the root that they beat as part of the ceremony that goes into it. Now, the thing about this is, so what they have is an experimental science within the limits of their knowledge, and it is functional and actually is, has its own type of validity that is very important. Not only does it have validity, it has extensibility. In other words, you can take your theory and extend it. It's also a very important part of being able to use a theory. So the theory of the fishing tree, the way in which it's extensible is the fact that neurotoxins, insects are very susceptible to neurotoxins. And since it is a neurotoxin, they could then believe that it is, somehow bringing them food. They could burn the root, and that would very likely poison bees and things like that, and they could gather honey better. But the problem is that they will then hit a wall at a certain point in their extension of theory. So the point here is that some theories are greater than other theories. They match more of reality. They are more extensible than other theories. And so, but there are theories that function within their limits. So, for instance, what I'm saying here is that the same thing is true of our current theories. They are very, very valid within the limits that they currently have on them. So, what else is it that theory does for us? What it does is it allows us the difference between acting like evolution, in which by trial and error, you eventually come to some sort of conclusion by just slamming things together. A lot of mathematical physics, actually, which in the Kuhn cycle was called the normal science, that actually is that banging things together till something sticks. But then instead of that, there is projection into white space. There is the ability to know that these things go together in a certain way, and so you can actually have a limit on your infinite search. You don't just bang anything together in any way at all whatsoever. You test within borderlines defined by that projection of your theory. So the theory is extremely, extremely important in actual real innovation. In other words, that is the difference between understanding and what evolution does, which it does develop extremely complex systems via trial and error. And instead, by limiting the search space, theory brings us much faster to an answer that gives us innovation and engineerability. So I wanted to go through a couple of quotes here. History shows clearly that the advances of science have always been frustrated by the tyrannical influences of certain preconceived notions, which were turned into unassailable dogmas. For that reason alone, every serious scientist should periodically make a profound reexamination of his basic principles. That is Louis de Broglie. And he is, of course, a father of quantum physics. And then the longer quote, I'm just going to say, science advances one funeral at a time, Max Planck. And you kind of can get the point here that a lot of scientists, going right up to Kuhn's structure of scientific revolutions, understood that there is an issue with the fact that you cannot stand on the shoulders of giants without having some level of faith in the evidence and the interpretation of the evidence and that the people before you have done their job. It's the only way you can specialize and spend a lot of time moving forward is by having some level of faith, and that faith is hidden from you. And that is why dogma appears in science and why there is a semi-religious sort of behavior, because it is a requirement that you not go and re-examine absolutely every prior axiom, otherwise you will not progress. So that is part of the reason why we have these revolutions being necessary. So I want to go into a little bit of the highlights of the timeline for Ether that are relevant to this discussion, because it is important to note that there is not just any Ether that you can use. You can't just hand wave. There is only a particular, very specific development of Ether that leads to all of the other aspects of science. There's a very narrow path, extremely narrow path that can fit our current experimental regime and our current physics. So in 1818, Augustin Jean Fresnel, I'm butchering his name, of course, publishes a memoir on the diffraction of light and establishes the coefficient of ether drag. So in this, he actually is proposing the speed of ether through a medium like glass. And one of the things that he does is in using the wave equation, and this will come up later, he uses increased density inside of a medium causes light to slow, was his presumption. However, it is exactly equivalent to presume that decreased rigidity inside of the medium is actually responsible. So those two things are equal. I want you to keep that in mind for much later on. But the important thing to note here is the coefficient of ether drag. Von Laue shows is equivalent to relativistic velocity addition later on after relativity. So 1839, James McCulloch publishes an essay towards a dynamical theory of crystalline reflection and refraction, and in which he proposes a new form of elasticity for the ether, and it is held to be non-physical. So that is one of the claims, one of the understandings that happened at that period of time, is that this sort of ether is they can't think of a type of our typical elasticity has to do with crushing and moving of particles in a very particular way, and we are still at this point in history developing our theories of elasticity. And that's something that Kelvin will do a lot of work on. 1851, Fizeau performs his famous experiment to determine the actual drag component of ether, and he proves Fresnel perfectly. Okay, in other words, what Fresnel predicted was exactly the amount that that light was dragged along by the water in the tubes where he shot light back and forth across it. That is very important to understand. Fresnel predicted it. Fizeau showed that it was absolutely true. Then in 1855, we know James Clerk Maxwell. He uses inviscid fluid mechanics. It's very important to explore on Faraday's lines of force. And what he's talking about is, though I will often substitute the vortex, the line of the center of the vortex for the line of force, he was actually talking about the fingers curling around as lines of force instead of the thumb. Okay, and so he describes the vacuum based upon molecular vortices. Both on Faraday's lines of force and on lines of force were very long papers going into great detail. And once again, this is inviscid fluid mechanics, which means it is a non-compressible fluid. And so once again, we have a type of wave that is not familiar to the people of the time. Okay, 1867, Kelvin, so Thomson and Tate published a treatise on natural philosophy. It's a groundbreaking seminal work on fluid mechanics, hydrodynamics, and elasticity is still foundational today and relevant today in a number of fields. And also in 1867, Kelvin publishes the vortex theory of the atom, which is a foundational paper for knot theory. Now, it is actually that is where knot theory came from, and it is a model that is also in an inviscid fluid, which is therefore compatible with Maxwell and McCulloch. 1845 to 1886, the Stokes complete ether drag model is dominating for some reason in people's opinions over Fresnel's partial drag because of aesthetic convictions alone. They don't have a real good reason for it. They just don't like the idea of partial drag. And so it just sort of becomes popular within the community. However, partial drag does account for all the optical ether drift experiments sensitive enough to detect first-order effects such as Arago, Epizo, Hook, Airy, and Scart, and is fully compatible with observations of stellar aberration, because that was the main problem at that time, was stellar aberration. We see the movement of starlight depended upon the orbit of the Earth, and that it was thought to be difficult to explain. There's a couple of things that we'll go into in some other presentation, but for now, just simply understand that that was what they were trying to resolve. And partial ether drag, because it is a small component, would actually be compatible with all of those observations. 1887, Michelson conducts the eponymous landmark experiment with expectations of full drag or none. He does not actually think of it or talk about it in terms of partial ether drag, because that was not the current favored ideology. And he reports an east-west wind that was 1/40th of the expectation value. Now, I'm putting emphasis on things here because it's very important to understand how it was that he reported the paper, and I really recommend that people go back and read the original paper and look at the actual data and plot it themselves. So, however, he conducted this experiment with white light and in open air, and these things are both very important. And what it did show was a characteristic dual sine wave of results. It was not random. It was not a random plot. It was a dual sine wave, exactly as would be expected of an ether wind. And that speed would be at its maximum between 8 and 12 kilometers per second. At a minimum, that was one calculation, taking the straightforward calculation. However, if you expect that a relativistic ether, which we will be discussing further as we go along, then the only thing that it would be measuring is the ether drag in air, which has to do with the index of refraction of air. And that would be roughly 300 kilometers per second, according to Fresnel's drag. So understand that the Michelson-Morley experiment in the appropriate ether theory does not detect anything other than the ether drag of the air. And so therefore, of course, it will be perfectly null in a vacuum. And we'll continue on from here, however, because I do have to give an overview, because there's a lot of information I need you to get all at once to be able to understand the total picture. And then we'll deep dive at a different point. So the Michelson-Morley experiment has never actually been replicated in history except by Dayton Miller. He did tens of thousands of experiments, and he actually was one of the first people in physical sciences to do a double blinding procedure where the person performing the experiment, the person writing it down, neither one of them had any idea what was going on. Really, really interesting science. He also duplicated exactly the same results of the Michelson-Morley experiment, with the variations having to do with the sidereal day and the equinoxes and the solstices, which have to do with the distance of the Earth from the sun. So he got the same results as the Michelson-Morley experiment at 8 to 12 kilometers per second. Now, you have to understand, let me continue to digress just a moment on the Michelson experiment. When Michelson reported the 1/40th, he was talking about only the east-west component. Now, that is not taking into consideration that the wind might not simply be an east-west component. And secondarily, because it is a second-order effect, there is a nonlinear relationship between the speed that it means and the reading that you get. That is why the actual reading that he get, even in a straightforward looking at it, is 8 to 12 kilometers per second, which is 1/3 of the expectation of 30 kilometers per second. So there's something to understand about that experiment that a lot of people have not properly discussed. Let's continue forward. 1889, Fitzgerald publishes the first expression of the relativistic factor of change. Now, a lot of people aren't aware of that. It was something only recently discovered by historians, that he was the first to publish it in its simplest form. So he mathematically was intending to describe an illusion caused by ether's anisotropic effect on the propagation speed of light, which mimics constancy. So in other words, what I'm trying to say here is that Fitzgerald was mathematically modeling what would happen to a Michelson-Morley experiment and how it could end up being null, even though there is definitely an ether wind impacting the motion of light. And so there's, instead of, like, for instance, going across the wind, it would have to travel at a triangle. And of course, when you're going up into the wind and back, it's going to slowly catch up to the leading mirror and then bounce back quickly. That is mathematically expressed in a certain way. That is what exactly the change factor is, a mathematical expression of that particular attempt to model an illusion, a perspective illusion. Very, very important to understand. Okay, then I continued too far forward. In 1889, Kelvin publishes on a gyrostatic adynamic constitution for ether and solves the non-mechanical claims about rotational elasticity, thus giving a fully workable mechanical model of the field concept. So a lot of people in history are aware that that McCulloch and Maxwell are responsible for the field concept, and that it is related to this concept of rotational elasticity. Now, keep in mind, Kelvin is one who gave us our original understanding of elasticity. Then he also continued forward right after the Michelson-Morley experiment and gave us a model of rotational elasticity that is physical in nature. He built models, etc. This is a lost part of history. A lot of people have forgotten. Okay. Now, 1889, 1904, the Maxwellians, great book by Bruce J. Hunt, including Fitzgerald, Heaviside, and Hertz and Lodge, used concepts from McCulloch and Kelvin to reorganize and re-express Maxwell's work. So the papers that Maxwell originally did, the 4 equations of what we call Maxwell's equations, they were actually given to us finally in their final form by Oliver Heaviside, one of the Maxwellians. And So simultaneously at that same time, Heaviside, working with Kelvin, develops a model of electromagnetic effects that account for physical length contraction of particles in ether. By particles, I mean Kelvin's types of particles, which are these vortex atom model type particles. And Lorentz fully articulates the kinematics of relativity, but his electron model is lacking. So you have to understand Einstein's paper on relativity on the electrodynamics of moving bodies. His first part, the kinematical part, he is re-expressing what was already done and well established for 15 years before him. It was not in any way questioned that all of the length contraction and time dilation had already been established. Time dilation was given us by Larmor. He was another person who was working closely with Fitzgerald and the rest of that group. So what we have beforehand is the electron model by Lorentz with the kinematic model. So that you have to look at it in 2 parts. So then in 1905, simultaneously, there's a little publishing error we won't talk about. That's too much of the history. But Poincaré and Albert Einstein both articulate this mathematically equivalent extension of Lorentz's work to replace Lorentz's model. So Lorentz has his own electrodynamic model. It doesn't work. Everybody says, everybody agrees it's got problems. Poincaré and Einstein both give the secondary part. So that is the electrodynamical part. Einstein was not claiming the kinematical part. He was explaining the kinematical part. Einstein's, what he was giving us was the electrodynamical part, the second part of the paper. So in his paper, he eschews the necessity of discussing the ether for the extension of electrodynamics. In other words, he kind of gives us the first version of shut up and calculate, because there are these various debates that have been going on for far too long about the ether. And so he wants to just end the debate and move forward, is kind of his view of it. That there's no need for us to look at that because this works just fine this way. We don't have to consider it. Let's just move forward. But the thing is, the Poincaré's exactly equivalent model is mathematically equivalent. This is all historians agree about this. His mathematically equivalent model works within ether, but it both requires and grants additional components to maintain the mechanics of the illusion initially described by Lorentz, Fitzgerald, Larmor, and all of those who developed the change factor. In other words, the cause of the change factor is the motion of the ether and its effect on light. That is where the change factor comes from. That is what is a description of, and that was still required within Einstein's version. Poincaré's version. Okay, 1907, Hermann Minkowski conjoins space with time and articulates a useful mathematical formalism, which presupposes isotropic constancy and conjoins space with time, thus promoting reality to a true 4D without any empirical basis to add the possibility of infinite additional 3D realities embedded in one single moment. So what I'm talking about here is that 1905, we have these two equivalent theories. One works in ether, and and they are mathematically equivalent. One just doesn't think about the ether. And in 1907, Minkowski then produces a mathematical model that gives a very specific differentiation point. This is a bifurcation point in the history of physics. When Minkowski does this, and this is an addition in relativity, it is not relativity. It is a non-empirical actual addition to relativity, and I'll discuss further later on. But it is cannot be falsified according to modern scholars. So what you have to understand is there is a difference between anisotropic constancy and isotropic constancy, and this has to do with the one-way speed of light. So that is there an effect in the Michelson-Morley experiment where light traveling up and back, no matter what speed you're going, it's getting shortened just the right amount to always come out to seem constant? That is the Poincaré relativistic ether version that they were working on for 15 years before before Einstein's paper. Or do we simply believe that light travels the same speed in all frames of reference in all directions and that there is no illusion? That is codified in Minkowski's methodology. You have to understand that it is mathematically codified in that methodology, and it is a claim that does not have empirical basis for that claim. So when you codify that, you have to conjoin space with time. It is a necessity for it to mathematically function, and you have to promote reality, because you have to understand, though they were using the four-dimensional, the fourth dimension in the prior theory, with Lorentz and Poincaré, it was not a true additional dimension as much as it was just simply a way of keeping up with time differences, because those time differences were very real, because it had to do with the difference in how electromagnetism mediates process. However, when Minkowski gets involved in 1907, what he has done is instead promoted the dimensionality of reality in his theory. And what I mean by this is one single moment is four-dimensional. And that means that it's just like if you take a two-dimensional sheet, adding a third dimension allows you to have infinite additional two-dimensional sheets, infinite additional ones. So by promoting reality, you have basically allowed the ability to have infinite additional 3D realities in a single moment. So understanding this difference between using a fourth dimension as simply a notation for time differences and clock differences and things that are really a difference in process that are measured by clocks, versus altering and promoting the dimensionality of reality, that is only Minkowski's addition. And there is no empirical reason to do so, because we already had the empiricism developed for relativity prior to that point. So understanding that it is non-empirical, and not only that, it is claimed that the one-way speed of light can never be measured in modern times, which means you cannot falsify space-time, because that is the differentiating experiment between relativistic ether, which is by all historians is known to be mathematically equivalent with the Minkowski spacetime. So let me take a drink real quick, and I will continue in just one moment. So 1907 and 1909, Einstein publicly quips about spacetime: since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore. We don't have an exact date, but it was specifically him talking about spacetime. So he has therefore publicly insulted his former teacher and mentor Hermann Minkowski. 1909, this enormously influential figure in the very small school of German physics unexpectedly drops dead from appendicitis. David Hilbert writes his obituary. Max Born delivers it at Göttingen. This is, of course, two major figures in physics of the time. I simply pointed that out for those who are aware of these influential figures in physics. So around the 1912 era, numerous polemics between Einstein and other scientists. These are public polemics, in other words, arguments in the public discourse. They pressure him to use Minkowski's formulation, and Max Abraham, in particular, who's supporting a non-relativistic ether theory, publicly and falsely accuses him in Annalen der Physik, that's the major publication at the time, of giving the death blow to relativity by exploring variable light speed or anisotropic constancy. So that is counter to Minkowski's isotropic model. So he's being ridiculed. First, he's pressured, then he's ridiculed. And there's this fundamental misunderstanding because he is continuing. There are multiple times that Einstein says that we have to give up the idea of constancy. And what he means by this is isotropic constancy, not anisotropic constancy. In other words, he is starting to support one model, which is the relativistic ether, over the other, but only partially. So 1915, Hilbert uses Mie's 4D generalization of McCullough's ether to approach general relativity. He works so closely with Einstein during the publications of GR papers that some scientists give primacy to Hilbert for GR for many years afterwards. It's only been very recently that people have found some little particular paper that has kind of answered the question, and for a lot of people to say that, no, we still believe that Einstein should be given primacy for GR. But the point is that they were actually corresponding very closely, and Hilbert did sort of independently come to general relativity as well. And they were, at the time that Einstein was publishing, they were working together. So it's kind of a collaborative effort, if anything. And then Hilbert is also a staunch promoter of space-time developed by his best and truest friend. In other words, Minkowski is Hilbert's very best friend. And he also states he was closer than any brother. So understanding the social environment, and the fact of the matter is, once again, when you have two mathematically equivalent theories, it's only a very subtle differentiation point that makes a bifurcation, because they are interworkable, which means Minkowski's formalism will work for most considerations of the ether version. All right. So these are a couple of the quotes by Einstein between 1907 and 1923. It's just a few of them. I've got at least 5, I think it's maybe 6 or so, and you could probably find more if you kept digging. However, the writer of these lines is of the opinion that the theory of relativity is still in need of generalization, in the sense that the principle of the constancy of the velocity of light is to be abandoned. On the other hand, well, I'm just going to read some of the excerpts here. It's not to be regarded as independent of the gravitational potential. In other words, it is locked to the gravitational potential. You must understand constancy in the context of the gravitational potential, which you have gone away from the previous theory of special relativity and into the more general theory, general relativity. So the constant of speed of light no longer holds, is another thing he says. This theory of special relativity therefore applies only to a limiting case that is nowhere precisely realized in the real world. That's Albert Einstein, numerous quotes. So I'd like to take a moment here to say that basically still ether is marching forward in the background. 1906, Poincaré writes The End of Matter. It's a very important paper. He articulates the mass energy equivalence. He further articulates mass energy equivalence in terms of ether theory, which he initially explored in 1900, which was cited by Einstein in explaining that electrons are holes in the ether. He basically talks about the fact that they are finding that the mass of a particle is, they first had a rest mass, and then a inertial mass, and basically he was finding that there was no inertial mass, so there was no mass according to what he was understanding within his theory, and that is why he came to the idea of holes in ether. And like I said, that was the continuation of ether theory. In 1909, the Kosserab brothers write the theory of deformable bodies, thus encapsulating all prior rotational models of McCullough, Maxwell, and Kelvin's ether into a successful continuum model, which describes superfluid behavior. And what I'm saying is that is the model of ether. It's been rediscovered in the 50s and is used as in material science. It's called micropolar elasticity. It's far better than a lot of other continuum models, but it is also a way of describing superfluid behavior. And I'm saying that it is the superior model of treating ether, and is really the only model of ether that will work to analogize all of our various particles and things of that like that in modern physics. 1913. Georges Sagnac, I don't know how to pronounce his name. It's driven me crazy for years. He demonstrates the effect bearing his name, revealing an anisotropy in the speed of light that contradicts the fundamental constancy postulate of special relativity, but not the illusion of constancy found in relativistic ether. Now, a lot of the descriptions around the Sagnac effect are very, let's say, I don't know how to put it nicely, but they're just dumb. And it basically, the Sagnac experiment just shows the exact same thing that Einstein was getting to, is that the constancy doesn't actually fully work. It is an idealization. And what we're finding through all of these various experiments is that constancy, anisotropic constancy, two-way constancy, where there's a compensatory illusion, that is functional. So 1916, 1920, Ernest Sommerfeld, German physicist who later makes significant contributions to quantum mechanics, publishes key works exploring the quantum theory of spectral lines, giving us the central guidepost of quantum theory, the fine structure constant. His continued work repeatedly mentions a medium through which electromagnetic interactions occur, explicitly highlighting his underlying belief in the necessity of a medium. So, and then in 1920, Einstein gives a speech at the University of Leiden, which can be summarized with space without ether is unthinkable. And now one of the arguments about that is like, oh, he was just talking about space-time. No, he wasn't just talking about space-time. For in such a space, not only would there be no propagation of light, but also no possibility of existence for standards of space and time. So no propagation of light, meaning it is a light-bearing medium that he is referring to. He says it explicitly right there. So understanding that what he is referring to is relativistic ether, but he is still loyal to Minkowski and Minkowski's mathematical model is extremely functional within limits. And those limits are for absolutely most, but the overwhelming majority of circumstances, the Minkowski formalism will function. However, it will give you a very bad theory about how reality functions. And there are certain edge cases that you can explore, and that that I've already sort of pointed out some of the issues here. 1922, Erwin Madelung, a German physicist, publishes Mathematics. Oh, I don't know how to pronounce that. A work that introduces mathematical tools for physicists with a focus on using fluid dynamic analogies in physics, further establishing a theoretical framework for understanding the ether. So understanding that there is, at the same time right now, there is there's a change in what's happening in Germany, and the German science is starting to dominate in a certain way. 1923, remember I mentioned Dayton Miller. He was a respected physicist at the Case School of Applied Science. He announces a detection of an ether drift based on years of meticulous experiments. His findings, which directly challenge the foundations of relativity, are met with skepticism and resistance. But he wins the 1923 Newcomb Cleveland Prize from the AAAS for the successful detection of ether. And he actually is the reason why Einstein did not receive a Nobel for relativity, because he was proving that there was an ether. Unfortunately, he had the more simplistic, non-relativistic idea of ether in mind, and that is not functional. Only a relativistic version of ether is actually functional. In 1924, Louis de Broglie completes his research on the quantum theory, which it describes the wave nature of matter, wherein pilot waves produced via a difference between relativistic frames guide the motion and nature of a particle in a way only relativistic ether can accommodate. You need to read that paper, and you will recognize there's a difference between the frames that require a preferred frame of reference, which is what Einstein eventually calls the Machian frame, or gravitationally defined frame. There's a wide variety of ways in which he speaks about the ether as a preferred frame, and general relativity is a preferred frame theory. In 1926, Schrodinger publishes Quantization as an Eigenvalue Problem, which he introduces the Schrodinger equation, and in it he prolifically cites, describes de Broglie's papers as primary source, and he is developing a physical model. In other words, the waves are physically real, and what he's talking about, which is why the Schrodinger equation actually gives us spherical harmonics. They're roughly equivalent. You'll find that whenever you look at spherical harmonics and whenever you look at our actual electron shells, they are basically the same. So he is going from there. So now I'm going to take a moment and we're going to jump forward, because what I've established already has given us kind of a starting point to talk about what exactly is the ether, how does it work, and what evidence do we have, so we can start working backwards from our most recent developments and how that's going to give us some value. I'm trying to fit in a lot of information all at once, so you'll have to excuse me. I'm going to take a second drink. This is requires a little bit. So we have Madelung giving us the hydrodynamic. He casts quantum theory in hydrodynamic form successfully. I didn't mention that yet because I just made these. It's actually a little bit further down in my slides here. And basically through the Wigner-Weil transform, we have a way of understanding quantum theory from a hydrodynamic perspective and transforming between them. That's one of the ways in which we will probably first start to match up our analogies with our current physical models to the fluid model, and how we'll be able to transfer over to a fluid model. But so what we're going to do now is start working backwards towards Madelung, Schrodinger, and de Broglie. So these are some slides I pulled from a different place because I was working till like 3 or 4 in the morning on this, so I had to pull it from a different one here. So here's the most recent way of showing that there is a model of quantum physics and the apparent stochastic behavior that we no longer need to accept that reality has this pure randomness at the bottom. We can instead expect that there is something called chaotic determinism. This is something, as we start to understand chaos and feedback loops and the complexity of evolving systems, that we now can have something underlying. In other words, the quantum physics, it actually is the probabilistic treatments are saying something very real, but probability is a way of treating something that is extremely complex and has a lot of detail in a way that you can kind of grasp the big picture of it. However, if there is something underneath that probabilistic treatment, then there may be additional ways to exploit that additional layer of information. So in other words, what we're talking about here is below the stochastic treatments. And so here what we have is the Yves Coudet comes up with the silicone walking droplet experiments, where a droplet of silicone is taken from the main bath, which is driven at a frequency below the Faraday threshold, and then with that droplet, when released, will bounce indefinitely on the surface. And then one of the ways in which it expresses itself, you'll see in the top right hand image there, it will simply move around the corral in what looks like a random pattern. However, that random pattern over a period of time is the Faraday wave mode of the cavity, which is exactly what we see whenever we trap an atom in amongst other atoms. We see the same form of waves. And so you can see there are a variety of ways in which the researchers in the silicon Walker experiments have proven the dual slit experiment, quantum tunneling. Every quantum behavior can be shown to be analogized by this. In other words, there is a way in which we can show that there may be a system, and that system, and I'm saying it's ridiculous to not accept that this is the appropriate system, because you're actually accepting that there's randomness below the surface is a magical belief, in my opinion. But this gives us an actual layer of determinism to go back to a more mechanical version of reality. And at this point, if I could ask you to bring up one of my favorite videos, because I did want to show some of the other behaviors live. And there's a great little video that I sent over to you, and it is, let's see, it is in my let's see. the best collection of pilot wave walkers videos is the third link in the video that I sent you. I mean, the follow-up email that I sent you, Tim. If you could,
yeah. Sorry about that. I'm juggling windows here. Okay, so let me bring this up.
Yeah, somebody just put a really spectacular collection of videos. It's actually kind of funny because they made it entertaining, but it is.
Yeah. And can I ask what was the name of it again? You sent me over a bunch.
It's the third one there, and it is the one I labeled the best collection of pilot wave walkers, and it actually is named pilot wave walkers when you go to the video.
Okay, because I have qubit walkers.
Yeah. Oh, yeah. Sorry, that was what it was called. Yeah.
Oh, okay. So let me bring that up. Okay. So sorry about that. Yeah, and we have just about 15 minutes left. So okay. So sorry about that.
So you can see these self-organization behaviors and these various modes, like where it's jumping, etc. In this this one image below, there's another one of the behaviors that it does. So there are quite a lot of quantum-like behaviors that we find. And John Bush at MIT has started to put together something he calls pilot wave hydrodynamics, which recovers all those various things.
Okay, there we go. Can you see that? Okay.
Yeah. Mm-hmm.
I'll put that in theater mode. Hopefully.
So here, so you can see there's one of the ways in which the wave that accompanies the droplet goes through the two slits. Eventually, you actually replicate the two slit experiment. Then you have these various formations of various patterns that are they're just reminiscent of a wide variety of behaviors that you see at the quantum level. And I just love some of these demonstrations. Like that one is one of my favorites. And so yeah, it goes through some of these, the locking together in various modes. You see these lattices. There's an instability of a lattice. Some of them rotating around each other. So that's a fun little video. And now there's one other thing that I would like you to bring up, if you could, in the background as well, and that is the first video, the first link I sent you, which is I think it's called I don't know, it's something German, and it's water sound images is the first link there, and it's cymatics, and it's about so it's a cymatics video, and this is actually really funny. I recommend you guys look at this this video because it's pretty funny. It's very entertaining. They did a great job with it. Can you bring up the water sound images one instead? That's the cymatics, science versus music. That's a one that's very entertaining, and really you kind of have to watch with sound, but that's not what I intended to bring up. I was just going to leave that as a video for people to watch. But these are various ways in which people are using Faraday waves, because cymatics and Faraday waves. Okay, here we go. So in this demonstration of cymatics, which is basically using the Faraday waves, you can see there that it is a toroidal vortex, and by the bubble that is circling along the top, and so this torus it's just a droplet of water that is driven at the correct frequency and amplitude combination. And now you'll see these alternating vortices in this direction, as well as vortices in that direction, and those actually match the d orbital shape that you're familiar with. And so you can see that there's this interplay of spherical harmonics that allow vortices to behave in very particular ways. And now if you were to go forward here, you'll find that there are various shapes that will arise. And you have to keep in mind there is a vortex or multiple vortices within these figures that arise when you hit the appropriate resonant frequency and amplitude of the waves, and the number of waves that are contained within one actually determine the number of vortices that are in them. And you'll find that, for instance, a lot of people I'm sure are aware of the hexagon on the top of Saturn. That is, it actually is 6 vortices that are kept together by mechanisms of resonance like this. But a lot of people are not aware that the same thing exists on the top and bottom of Jupiter. There is a octagon of vortices, and on the bottom of it there is a pentagon of vortices. So this wave vortex duality interaction is a very important part of the theory. And so I wanted to start to introduce some of these concepts as what it is that is, how does the mechanics of the ether lead to particle formation, and what is the relevance of knot theory. So what we're seeing here is the formation of knots through resonance because of the way in which waves have to pass through each other. There's a mechanical interaction that leads to rotation, and that is where we get these vortex filaments that are that automatically are instantiated by the waves that are going back and forth. So these are some of those solid ones. Let's get back to the presentation, if you don't mind. All right, great. So let me get to the next one here. So you have to understand the idea that Kelvin was talking about was this ring vortex model with vortex filaments, and that the lines of force and vortices were a critical and crucial part of the way in which electromagnetism worked, according to all the developers of electromagnetism. The only person who didn't explore this model of all the developers of electromagnetism, Heaviside, Maxwell, Lorentz, all of those, the only one who didn't explore this aspect of it was Einstein, actually. So what we find is that Kelvin's knot theory of atoms gives us some insights into newer theories such as skyrmions and solitons, topological defects, in understanding that what the ether may be like. And let me also just give you a quote in 1951 to understand that quantum, it did continue forward all the way into quantum theory, and Dirac wrote Is There an Ether in 1951, in which he finalizes it with we now have the velocity at all points of space-time playing a fundamental part in electrodynamics. It is natural to regard it as the velocity of some real physical thing. Thus, with the new theory of electrodynamics, we are rather forced to have an ether. And so this was kind of an answer to the only one thing that Einstein said that was incorrect in his address, that was space without ether was unthinkable, is he said the parts don't move against each other at the very end of it. However, we know that frame dragging or the lens throwing effect does occur. And then, of course, Dirac is also pointing out that there is a motion of space against itself. And so therefore, we also show that there is a movement of space that is relevant here. This is just a demonstration of a multidimensionality. That is the reversible laminar flow experiment that is a favorite of David Bohm's, who brought back pilot wave theory in a form that that people did not find aesthetically pleasing. However, John Bush, by using de Broglie's wave equation, which basically shows this feedback loop, which allows it to which causes that semi-random behavior. He actually shows a way in which pilot wave theory now is a functional, workable way we can think of how the pilot wave works. And so this actually gets into my paper on deterministic entropy, which I won't go into here. So just going back to the superfluid vacuum, one of the things that we look at down here in the bottom left, these are called plasma vortex crystals. Whenever you perturb a plasma, if it is allowed to be in a two-dimensional form, which means that it is very important that it does have those borders, then one of the things that happens is they self-organize into crystalline forms. And understanding that one of the things that we find in superfluids is the automatic arising of vortex filaments. That is just part of, as a wave travels through a superfluid, it ends up creating these vortex filaments that are all throughout it. And so what I'm saying is that there is, struck through the ether, there are these vortex filaments. They are a very important part of the way in which the ether works, and understanding them from Maxwell's and Faraday's perspective, we have a way in which we're connecting all the various ideas of electrons and the formation of particles. I'll have to get back to the reason why a 2D border is important to organizational principles. Let's see, from this one, we just wanted to see some of the self-organization of bouncing droplets. You see that those are very familiar things there. The one thing I wanted to point out is the idea of a cavitation. So you see not all of the of why that opens up is a gas. That's why it then collapses with the gunshot there in the bottom left-hand corner. It's one of the best examples that I can show you, but understanding that there is a way in which something can be opened up that is more of a vacuum is very important. But what we'll find in exploring this idea of holes in the ether as electrons is actually the combination of a wave on a vortex filament. So you have to understand that when waves go across vortices, they can be spun up by the presence of the wave. So therefore, when a wave combines with a vortex, what you can have is it crossing a threshold that causes the vortex to open up into a cavitation. And so this is one way in which we can model free moving electrons. This is some of the exploration of the holographic model. I'm not sure that this is extremely relevant right here, but just looking at the way in which waves come together. And there are some aspects of the, let's see, the ER equals EPR, the entanglement issues. Actually, you have to start dealing with holography, but I really shouldn't go that way because I'm running out of time. So let me just point out that basically electromagnetism organizes vortex filaments, which is what Maxwell was pointing out. So that is the organization of them. And what you'll see in a moment, I'll show as the last thing for my presentation, I'll show this when you use a Heelshaw plate, which is you trap a ferrofluid between two glass plates and light it from the side. You can actually visualize the lines of force in a different manner that gives you a better idea of the organization of the vortex filaments that I'm talking about. And basically the idea of gravity is that it is a bulk local vorticity. So in other words, it is the, I'm loath to use the word density, but it is the frequency, the amount that you will find these vortex filaments. The vortex filaments, as the speed of the ether is rotated very near the speed of light, that is what's able to cause the cavitations, because the speed of light is merely a measurement of the actual properties of the ether itself. So basically, whenever we go all the way back to Fresnel, and instead of using the density, increased density in an object, we instead have a reduced bulk modulus, or actually it's a reduced rigidity. Then what can happen is that will lead to the exact same equation for all of the same things. And what we have then is a method by which we might actually find at the quantum level there is a nonlinear effect, and which can allow for solitons. And basically our idea of bent space is that there is a slowing of light, and light is responsible for time because it is the mediator of communication of change between objects, or actually there's a slowed waves in the ether, whether that be gravitational waves or any sort of wave, because the waves are in fact ether. So I'm not going to get into the further stuff there, but basically what we end up finding in some of my other things here, and like I said, run straight out of time, but it looks as though as they continue forward, there's further developments of Madelung's theory, and then the Nazis self-sabotage themselves because they conflate relativity with no ether. Whereas what we've been talking about this entire time is that relativity and ether are fully compatible, and that there was a completely mathematically equivalent version of relativistic ether that Einstein was eventually supporting. And because of being jackasses, they conflated these things, and that led to them not advancing their science in very particular ways. And some of the interesting things we find is that these various meetings between Werner Heisenberg and Bohr, and the possibility that they were actually actively sabotaging the Nazis and that's why there was this secret meeting between Bohr and Heisenberg before he defects, and Heisenberg stays. Very important thing to note that Heisenberg did stay in Nazi Germany as part of their nuclear program. And so what I believe happened is he was actually actively sabotaging their program, and one of the ways in which he was doing that was by focusing on a stochastic treatment instead of a deterministic ether-based treatment. That will be it for this presentation, but we will just deep dive on the various experimental history, the linchpin experiments, the one-way speed of light that we mentioned, and then also we can get into holographic theory, rewriting string theory, and deterministic entropy and more. So thank you very much.
Well, Shiva, thank you. Thank you, sir. I genuinely, you were one of my favorite people. Like there is smart, and then there is your level of smart. And when you dig into this, it's the conceptual models and the history and just the wealth of knowledge and putting these puzzle pieces together. It just consistently blows me away. So thank you so much.